Hi guys, this is a video tutorial on critical path analysis for HSC students sitting for Business Studies CIE examinations. At the end of this tutorial, you'll be able to distinguish between an activity and a node, identify the critical path of a network diagram, calculate the total duration of a project, calculate the earliest start time of an activity, and lastly to calculate the latest finish time of an activity. Now let's step into identifying the critical activities or critical path along a network diagram. This is a network diagram of a firm opening a new production plant. It consists of various activities. Activity A, which is 10 days, activity B, which is 5 days, activity C, which is 6 days, activity D, which is 8 days, and activity E, which is 6 days. The project starts with activity A and activity B. These two activities can be carried out simultaneously, that is, at the same time. That is why they are called simultaneous activities. On the other hand, we can notice that activity C cannot start unless activity B has finished. So therefore, activity C depends on activity B. Same for activity D. Activity D cannot start unless activity C is finished and unless also activity A has finished. Therefore, activity D depends on activity A and activity C. Likewise, activity E also depends on activity D. Activity D ends here and then activity E starts. So these are dependent activities. Activity C, D, and E are dependent activities. Now let's get back again to this network diagram. So here, activity A has a duration of 10 days, while activity B and C has a duration of 5 and 6 days respectively. So it means that B and C in all, they take 11 days. 5 plus 6 equal to 11. They take 11 days. So for B and C to get completed, they take 11 days, while A take only 10 days. So what does that mean? That means that activity D cannot start unless these activities are over. So it means that even if A finishes up, D cannot start. But once B and C is finished, D can start. So it means that A is not critical. B and C are critical actually because they will determine when D really starts. For example, you can notice that even if A is delayed by 1 day, that is, it takes 11 days instead of 10 days, activity D, there is no problem, it starts on the same day. But if activity B and C are delayed, that is, instead of 11 days, they take more than 11 days, then this will penalize activity D. So therefore, we say that activity B and activity C are critical activities because they determine the project duration, because if there is any delay in these activities, they delay the whole project. So therefore, B and C are critical activities, but A is not a critical activity. So, in critical path analysis, how do we identify a critical path? Is by inserting those detour marks. So, B and C are critical activities. So, B and C are critical activities, and of course, we follow the arrow D and E. You will notice that if D and E also they are delayed, it is going to delay the whole project. So you'll understand it better if you do something like that. So let's calculate the project duration now. Let's calculate the project duration. That is, you take all the duration along the critical path. That is 5 added to 6 added to 8 and added to 6. So 5 plus 6 plus 8 plus 6, that makes a total of 25 days. So you will understand that if A is delayed by 1 day, that is, instead of 10, it becomes 11 days. 11 plus 8 plus 6, it still make 25 days. So it means that even if A has been delayed, it doesn't delay the whole project. But what happens if we delay, for example, one activity along the critical path? For example, C is delayed by, let's say, 1 day. So 5 plus 7 plus 8 plus 6, it gives us a total of 26 days. It means that the project is delayed. Likewise, if there is a delay in project D or project E, they are going to delay the whole project because they are found along the critical path. Any delay in critical activities will delay the whole project. Here you are. Nice. So now let's recapitulate. So we have got critical activities which are B, C, D, and E, because these activities, if delayed, are going to delay the whole project. So therefore, they become critical activities. Now, project duration. We add up all critical activities. That is, we take B, C, D, and E, and it gives us a total of 28 days. And it gives us a total of 25 days. So therefore, the project duration is 25 days. Here you are. Now let's talk about the earliest start time, that is the EST. The EST is the soonest time an activity can start. It is calculated from left to right on the network diagram. It is influenced by the preceding activities. It is always 0 in the first node. It appears in the top right corner of a node, as illustrated here. This diagram illustrates node number 3 and activity C with a duration of 6 days. The earliest start time of activity C here is 8 days. This means that the soonest activity C can start is 8 days after the project began. This means that activity C can start only 8 days after the project began. So that is the earliest start time of activity C. I shall use this diagram to illustrate how to calculate the earliest start time of all those activities in this project. So this project consists of several activities: activity A, B, C, D, E, F, G. A having an activity duration of 8 days, B 3 days, C 5 days, D 2 days, E 2 days, F 3 days, G 1 day. Let's calculate the EST. As I said earlier, the EST is going to always be written here in the top right corner of the nodes. We're going to fill those EST here. So let me make it brief. The EST of activity A, the EST is here. Activity B, the EST is here. Activity C's EST is here. Activity D's EST here. Activity F EST. Activity E EST. Activity G EST. So, as I said earlier also, in the first node, the EST is going to be always 0. I take this EST, I add with the duration of activity A, which is 8 days. 0 added to 8 gives us a total of 8 days. That's fine. Now 8 days added to the duration of activity B, which is 3 days. So 8 plus 3 gives us a total of 11 days. Now 11 days added with the duration of activity D, which is 2 days, gives us a total of 13 days. And here 13 days added with 2 days gives us a total of 15 days. But then there is a problem. We can't write 15 days here because here also we need to calculate the EST. So 13 added to 2 gives us 15. I write it here. And 11 added with 5 gives us a total of 16. So which of these two am I going to use as the EST of activity F? So pretty simple. Activity F cannot start unless these two activities, unless activity C or D and E are over. So D and E takes 4 days. 4 added to 11 makes 15 days. Activity C added with this earliest start time, which is 11, gives us 16. So activity F cannot start at day 15. It should start at day 16. That is, so therefore we need to take the largest EST that we get here. So therefore it is going to be 16, not 15. Same now. 16 added to 3 gives us a total of 19. And 19 added to 1 gives us a total of 20. Now let's tackle the calculation of the latest finish time, that is the LFT. It is the latest time an activity can finish. It is calculated backwards through subtraction from the last node. It is written in the right bottom of the node. LFT in the first node is always 0. Now here you have got an illustration of how we're going to write the LFT in a node. Here it is node number 3 with activity C and with a duration of 6 days. So how do we write the latest finish time of C? It's here. The latest finish time of C is 8. Now this is the network diagram we used previously to illustrate how to calculate the EST of those activities. Now we're going to use the same diagram to illustrate the calculation of the latest finish time. So as I said earlier, when we calculate the latest finish time, we always start from the back. That is here, last node. We work from the last node to the first node. So by default, in the last node, the LFT is always the same as the EST. That is, if a EST is 20, it is going to be 20 as well. Now, working backwards, we're going to subtract the duration of the previous activity. For example, this is 20. This is the LFT. This is the LFT of activity G. Now we need to subtract. So therefore 20 minus 1 equals to 19. Okay. Now here the same, to calculate the LFT. To calculate the LFT of activity C, we need to subtract. So 19 minus 3 is equal to 16. Back again now, we need to calculate the LFT of activity E, which is here. So 16 minus 2 equals to 14. Now here it might be a bit confusing. 16 minus 15 equals to 11. But at the same time, 14 minus 2 equals to 12. So which figure are we going to write? So what is going to be the latest finish time of B? What is going to be the latest finish time of B for C and D to start? What is the latest finish time? Is it going to be 11 or is it going to be 12? I bet you might guess the answer should be 11. Why 11 now? Because if project B ends at 12, for example, if it ends at 12, 12 added to 5 is going to be 17. So it is going to delay the next activity. But if activity B ends at day 11, then added to 5 days, it's 16. It's good. So if activity B ends at day 11, added with added with activity D, which is 2 days, 14 days, it's good. There's no problem. Activity D, it doesn't delay activity D. So when we calculate the LFT in this instance, when we calculate the LFT, we need to choose the lowest. We need to choose the lowest value. And we know well for EST it was the highest value. So working back again, 11 minus 3 equals to 8. And 8 minus 8 equals to 0. That's good. And you might guess if the answer was 12 here, 12 minus 3 is equal to 9, and 9 minus 8 equals to 1. So it's not good. It should be 0. The LFT of the first node should be 0, and the LFT of the last node should be the same as the EST of that last node. So that's all. Thank you. And don't forget to comment on our Facebook page, Business Studies, if you have any issues on critical path analysis. Thank you.